Homework 13, measures of average. Video 3, median. Like the mean, I think several of you are already familiar with the median. It's the number in the middle. But I would be remiss if I didn't give you its actual definition. So here it is. We're going to let the set containing x1, x2, all the way through xn. And again, these are just generically representing first number, second number, all the way to the nth number, however many that is. But let this be a ranked quantitative data set. And by ranked, I mean put in order from least to greatest, as both of these are. Sometimes when you're given a data set, it's not put in order. So before you go finding the median, put them in order. If n is odd, in other words, if there's an odd number of values, the median is the middle value. But if n is even, if you have an even number of values, then the median is the mean of the two middle values. There will be two numbers in the middle, and you basically average them, which means you would add them and divide by 2. I want to be a little bit more specific about locating the mean, though, because if you know how many numbers are in the data set, you can actually count to the correct position to locate the the median. Let's start with odd. If n is an odd number, if you have an odd number of values, then the median is in the parentheses n plus 1 over 2 position. So for example, if we had 11 numbers in the data set, 11 plus 1 divided by 2 is 12 divided by 2, which is 6. The median's in the 6th position. But if your n is even, then the median is the mean of the two middle values. So the median is the mean of the, and here's how you would locate the two positions in the middle. You would take the number of values and divide it by 2, so the n over 2th, and you would go to the next position. So whatever n divided by 2 was, you would add 1 to it, and it would be the average of those positions. Now, you don't need these formulas to locate the middle. I'm just saying, if you tell me how many numbers are in the data set, I can tell you exactly where to find the median. For example, let's say that we had 20 numbers. That's even. Then to find the two numbers in the middle, I would take half of 20, which is 10, and then add 1 to that, which is 11. I would go to the 10th and 11th numbers and average them. Let's take a look at a couple of specific examples. You might recognize these as the same data sets from the previous video. In the first example, we have a ranked data set, 5, 9, 10, 11, and 17. And recall that there are 5 numbers in this data set. That's odd, which means there's one number in the middle, and you probably already know where it is. It's right here, it's the 10. But in a really large data set, like for example, instead of 5 numbers, let's say you had 55, it might be real tricky to locate the center, the middle number exactly. You could trace inward from the ends and see where they meet. Or you could calculate where it is and just count out to it. If I wanted to calculate the position in the median, I would put 5 here. 5 plus 1 is 6, 6 divided by 2 is 3. I would go to the 3rd position. 1, 2, 3. Again, this one is small enough that it's pretty obvious that number is in the middle. But if it were a large data set with, say, 21 numbers, what position would the median be in? 21 plus 1 is 22, divided by 2 is 11. You would just count out to the 11th position, and there it is. All right, so the median on this one is 5. And by the way, there's not a consistent variable for median, so we'll just say the word median. And the median is 10. I'm sorry, I think I might have said the median is 5. But let's take a look at the other example, where we had the same data set, but we threw in an outlier, 5,000. This data set has n equals 6 values. That's even, which means there are 2 numbers in the middle. Do you know which two numbers are in the middle? It's these two. And again, with small data sets, it's often easy to spot them, but you don't have to guess if you know how to calculate the positions of the two numbers in the middle. If your number is even, to find the two middle numbers, cut that number in half. Half of 6 is 3, and then add 1 to that to get 4. Go to the third and fourth positions. 1, 2, 3, and 4. But we're not done yet, because when there are two numbers in the middle, the median is the mean of those two numbers. And the way you find the mean of two numbers is you add them and divide by 2. 10 plus 11 is 21. 21 divided by 2 is 10.5. So as you can tell, the median sometimes is not actually a number in the data set. In this case, it's not. The role of the median is pretty simple. Cut the set into two halves. About half of the numbers are less than the median. About half of them are greater than the median. Notice I said about. In this case, exactly half the numbers are less than 10.5, 3 of them. And exactly half the numbers are greater than 10.5, 3 of them. Back up here, how many numbers were less than the median? 2. Is that exactly half of the numbers? Not really. There are 5 numbers and half of 5 is 2.5. So it approximately cuts the data set into 2 equal pieces. Sometimes it does exactly, sometimes it's an approximation. So why did I use the same data sets from the previous video? Because, like before, I'm going to discuss the effect of having an outlier. Remember, an outlier is a number that is noticeably greater or noticeably less than the other values in the data set. In a statistics class, there's a more formal definition on defining who gets to be an outlier, but I think it's safe to say that 5,000 is a lot larger than these. But did adding that outlier drastically affect the median? Well, without the outlier, our median was 10. And with the outlier, it was 10.5. So the answer is no. So what that means is median is not heavily influenced by outliers. This is the reason why in a lot of news stories or reports you hear things like the median household income in this city is some amount, or the median home value in this state is that, because median is not drastically heavily influenced by outliers. So, for example, if you live in a neighborhood where the average house price is $150,000, and then somebody buys up 3 lots and buys a $500,000 house, does that really raise your house's value? If I average the numbers with an outlier, it's going to give the impression that all of our home values were elevated. But if we use the median, it's just going to bump it up a little bit. Probably bump it up a little bit. So median is not heavily influenced by outliers, whereas the mean is. Just remember, when you calculate the median, your numbers must be in order. Otherwise, anybody could be in the middle, and anyone could be the median.